Hello guys! Welcome to my YP channel. Hello guys! Welcome to my YP channel. And this time it's gonna be okay. And extraction. Okay, so we need to introduce um, formulas. So we have liquid extraction. Okay, shall we say, and we have solid extraction from liquid mixture, ternary liquid mixture, something like that, or a composition of immiscible liquids to another liquid, something like that. Okay, so the important here is we know the raffinate and we have the extract. Okay, something like that. Okay, so how can we compute for that? It's gonna be we need to know the distribution coefficient. So actually, the partition coefficient is the same with distribution coefficient. Okay, it's gonna be, let's say, m. Okay, mk is equals to the partition coefficient. Okay, guys, or this is also as distribution coefficient. Distribution coefficient. Okay, this one. Distribution coefficient and what is partition coefficient. Okay, M or K siya. And then since this is extraction is a physical separation process according to the difference in solubilities and concentrations. So we need to know the basic formula of concentration. Okay, what's that? So it's gonna be moles per liters. It's gonna be concentration C is equals to N over V. This one. C is equals to N over V, where N is the moles and V is the liters, so it's moles per liter. Okay, like that. So the same as solubility. Okay. So for example, if we consider a binary liquid mixture, okay. So we have, instead of using C as a concentration or solubility, it's just the same, okay? But we need to use solubility here. Okay, so for example, there are two binary liquids. We have, okay, S1, okay, like that. And we have also S and S2. Ganon. Okay, ganun siya. Okay, guys. So in this, we need also to, if there is concentration, we need also to determine the activity coefficient, something like that, or the activities, which is the A. So we need to have the ratio and proportion, right? For this. So ratio and proportion of, let's say, A. So this is A or alpha, right? This activity, okay, meaning activity. So we have activity coefficient. If you remember, activity coefficient equal to 1 is an ideal solution, right? So very important to know. Okay, so alpha, okay, or A lang siya para madali siya. Okay, we have A, subscript is 1, okay? And we have also A subscript is 2. Anan. So A is 1 activity of S1, activity of S2, meaning to say solubility in 1, solubility 2 in 2 binary liquids, something like that. Okay, so we have K, right? So K will be equal to, okay, since this is solubility 1 is directly proportional to solubility 2, something like that. Okay, and the activity is also directly activity in solubility 1 is directly proportional to the activity in solubility 2. Now we have K like that. So if we need to take the ratio and proportion of these quantities here, Okay, like that. So we can obtain uh, AS1 like that over AS2, right? Then equal also to S1 or S2, this one. So distribution coefficient or partition coefficient is equals to activity of the solubility 1 and activity of the solubility 2, referring to the liquids, right, is equals to the solubility 1 over solubility 2. Okay? So that's your equation. Okay, like this. Okay, so that's very clear. Okay, so how can we determine the S1 in terms of the fraction of solute? So we need to know also the fraction of solute as Q, something like that. Okay, so how can we do that? Okay, how can we do that? So let's say S1 is equals to Q1 plus Q2, something like that, no? But let's try to make it Q only, right? Get the point. So it's going to be, oh, okay, let's say, uh, sorry. So S1 plus Q is equals to 1. Okay, this one. S1 solute in S1 plus the solute, this one. So S1 plus Q is equals to 1. If you solve for the value of S1, it's going to be 1 minus Q, right? So, ano siya? Q is a fraction of solute. Okay? So, we can say S1 is equals to 1 minus Q. Okay? Ganun siya. Okay? Get the point? S1 is equals to 1 minus Q. And now we have also, okay, so our S2, if this is the case, so our S2 is simply the Q, right? So our S2 is simply the Q. Okay, it's gonna be S1, let's try, plus S2 is equals to 1. And then S2 will be equal to 1 minus, okay, 1 minus, okay, so 1 minus 1 is equals to Q. Am I correct? 1 minus 1 is equals to Q. Okay, then our S1 is 1 minus Q, right? This one. Okay. So it's going to be, actually, this is S2 is equals to negative Q if we try to do this. Okay. So if that is the case, okay, we have a negative Q. S2 is our negative Q. Okay. So if this is a negative Q, there's no fraction negative, right? You get the point? There's no fraction negative. So in this situation, because these are all solubilities, right? There's no negative concentration, something like that. So we need to have another option. Okay, how can we do this? Okay, we can say, okay, we can say that this is S2. Okay, we can say that S2 is equals to plus Q is equals to 1. Therefore, S2 is equals to 1 minus Q. This is our another equation, this one. Because if you use S1 plus Q, it will yield a negative Q if in getting the S2. Okay, so we will adjust it. Actually, it looks like a trial and error. Okay, like that. So if we said S2 plus Q is equals to 1, then S2 is equals to 1 minus Q. Okay, guys, like that. So since we know S1 plus S2 is equals to 1, diba? So S1 plus S2 is equals to 1. Then the value of S2 is 1 minus Q here. We need to substitute that here. So S1, S2 is 1 minus Q is equals to 1. Okay, this one like that. Okay, take a look. We have the value of S2, right? In here, S2 is equals to 1 minus Q, and we have S1 plus S2. Solubility in 1 plus solubility in 2 is equals to 1. Okay, like that. Okay, so this is going to be like S1 plus 1 minus Q in here, in which we have here, is equals to 0. So in algebra, we have to treat this one, cancels out the left and right, which quantity or figure have the same. Di ba? May 1 dari ari, positive, and it's okay 1 dari ari. So you should cancel the 1. Okay, so it will become S1. Okay, S1, cancel ang 1. So this is equal, negative Q is equals to 0. So S1 minus Q is equals to 0. So transpose algebra again, S1 is equals to Q. So since our S1 is equals to Q, so this is now valid because we have a positive weight fraction of the solute, which is the Q. In here, in our first assumption, okay, our S2 is negative Q, in which it is invalid. There's no such value of negative for the fraction. It can be for the concentration, meaning it slows down the concentration from the reactant to the product as it's become negative. But that is fraction. There's no such negative fraction. It's always whole number, point something. Okay, point something, then you multiply that by 100%, it will become, for example, 10%, 20%, 30%, up to 100%. It will not go beyond 100%. Okay, but there's no such negative. So this first option is wrong. So this is correct. Our S1 is equals to Q. So we have now S1 is equals to Q, and we have now S2 is equals to 1 minus Q. Okay, we will use these quantities to solve. Okay, like that. Okay, now we have now like this. Okay, okay, ganun siya. Okay, so how can we use this one? So this, since we are dealing with concentration, di ba? C is equals to NV. You get the point? So what is a number of mole? Dire siya, concentration man siya, God, or solubility. C is equals to NV. So what do we mean by N? This is number of moles. So if number of moles, relate siya sa molar mass. Right? So molar mass is equals to the number of moles over the volume also. Correct? No. Over the molar mass is equals to the mole over the mass. Okay? Let's make it clear. So molar mass, which is the molecular weight, let's say capital M. Molar mass or molecular weight, marami na siya. So equal to molar mass, small letter N, and then mass, which is small m. Okay, nanatay ingon ni ani. Okay. Ingon ni ani nga equation, di ba? Molar mass equals to N over N. Okay, now, so N is the molecular weight times M, something like that. Okay, you get the point? So now, so concentration is equals to N over V, something like that. So since we have the 1 minus Q is our weight fraction, something like that. So how can we relate that to in terms of V? Something like that. So we can say solubility 1 over solubility 2 in here, in the first equation, right? So kasama na itong solubility 1 is equals to Q, right? Solubility 2 is equals to 1 minus Q. Okay, so this is our solubility fraction. This equation. Solubility fraction is equals to Q over 1 minus Q, di ba? We have solubility fraction. Now, we need also to get the fraction of the concentration in which here na talaga siya, hindi na kailangan. Okay? So, ang N1 and N2, So it could either be C times V, right? Ganon siya. So how can you achieve that? Okay, so let's say N1 over N2 na punta. Okay? Here. Okay, number of moles of the liquid 1 over the number of moles of liquid 2. So we have N1. Okay, we have N2. Get the point? Like that. And then ang ino na to is molar mass. Okay, 1 M1. Then molar mass M2. Ganon. Diba? Mano siya. So we have also an equation in 1 over N2 is equal to molecular weight 1 times the mass 1 over the molecular 2 times the mass 2. Okay. Okay. Now, in terms of volume, okay, in terms of volume, how can we do this? So this is in terms of masses, in terms of volume, we have here also, right? So we can say N1, N2 is equals to C1, V1 over C2, V2, right? Correct, did it? Okay. So mo po ning imong N1. This one. Okay. N1 over N2 is equal to C1 over V1 times C2 V2. So we have now equation 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, Diyos ko, ang dami. 8, 9. So we have now 9 equations. So in this topic, so 9 equations. So we need still have another equation also in terms of the K, right? Since you know that the solubility is the concentration chuba chuchu, di ba, in 1V1. Ganun siya. So in 1V1 over into V2. Okay, K. Another equation. Okay. So be consistent lang yun siya, guys, na dili ka magpataka. Okay? So K. So K is equals to is one solubility. We said concentration N over V. So we can say in 1 V1. Okay? C1 man siya. In 1 V1. Okay. So over into V2. Diba? Concentration man siya. Okay. Ganan. Right? Mo na imong K. Now, this is equation. We have also N1 over N2 here and C1 over C2 here. Okay? Like that. So if you try to solve for that in terms of V1, right? Okay, N1 over V1. You get the point? So N1 over V1 into over V2. So we need to make it into N1 over N2. This one is cross multiply. Okay, cross multiply. Since we make the N1 over N2 the same as here, because we are consistently saying that N1 over N2, we need to get in terms of N1 and N2. And through this equation, okay, that is 1 over N2 lang siya. Okay? Take a look. Okay, 1 over N2 V1 di ay siya. Okay? Para makancel ang kuan ang habilin lagyan mo siya in 1 over N2. Okay, our purpose is to get the N1 and N2 man. So multiply both sides of 1 over N2 V1 just to make parallel with this or similar with N1 that we compute in base of molecular weight and mass and volume. So let's do now the 1. Okay, 1 V1 V2 times K is equals to okay. Ano siya may tabo? Okay, so cancelo ni mo V1, so cancel, so N1 over N2. Okay, so it's gonna be, sorry, this is V1, V2. Sorry. So this is N, cancel man siya. Okay, again, I will do Okay, hugaw siya. I will repeat ha. We need to multiply this by V1 over N2. Sorry. Hugaw juga siya ang balikon. Okay. So, if we multiply N2 V2 over times V1 over N2, so we need to cancel. It will become V1 V2 times K. Right? And it will become consists of N1 and 2. So this is another formula of N1 over N2, right? This one. So another formula of N1 and N2 is equal to V1, V2 times the K, which is the partition coefficient, okay, and the distribution coefficient is equal to N1 over N2. So we have equation number 10. Okay, this is equation number 10. Diba? So equation number 10. Okay. So we have 10 equations to be used. Something like that. Okay. So this is V1 over V2 times K is equals to N1 over N2. Okay. Like that. You get the point? So if we need also to relate that with Q, right? Because we said, okay, because we said here, in terms of S2 also, we have S2 here, right? Okay, we have S2 here. So we can say K, okay, K is equals to S1, which is Q. Okay, S2, 1 minus Q, right? Supposedly. So this is the equation. And now, we know the value of K in terms also of this equation, right? There's a K here. So how can we do that? So we need to multiply that to V2 over V1. So that mahawa na po ang iyang kuan. So V2, V1. So K is equals to N1, V2, N2, V1. So muna siya. So K is N1, V2, N2, V1 here. I-substitute mo sa K, dire ari, in terms of Q na siya. So it's gonna be N1, V2, N2, V1 is equals to Q1 minus, okay guys? Okay, this muna na siya. Okay? Tanawa. Okay? Now, i-simplify ninyo mo siya. Kani siyang equation, this is equation number 11. In terms of Q, i-simplify ninyo mo siya. Di ba nakagap mo siya yung concentration ni Rara? Okay, moles per liter. So this is in 1 V1. So it's gonna be solubility 1, V2, N2 is equals to Q1 minus Q. This is equation number 12. So a lot of equations ha. Magtutuyok rin yung kaanin niya. Muna mong gamitan para me. There are equations 12. So kung paano sa mo ang S2, okay, in terms of Q, so since you have that S1 also value in terms of S2, right? So that is, okay. So masolve rin po mo in terms of S2. You get the point? S2, 1 minus Q. Okay? Kung mo ang Q, Q is equals to S1. Okay? Ganon siya. Q is equals to S1. So, ang mahitabo nining gayon na, kung S1 is just equals to Q, so mayroon ka nga Q V2 over N2 is equals to Q1 minus Q. Take note, the Q here is in the numerator, cancel the pugka. Okay, so Q, then cross V2, 1 minus Q. Okay, V2, 1 minus Q, and then N2. Okay, so N2 is equals to V2, 1 minus Q. Okay, this one is equation number 13. Okay, like that. So N2 is equals to V2, 1 minus Q. Okay, then you can also solve for V2 is equals to N2 over 1 minus Q. This is equation number 14. Okay, so there's a lot of equations to be used. So N2 is equals to, okay, V2, 1 minus Q. So these 14 equations, oh my gosh. These 14 equations, you will be use this in the solvent extraction. But of course, you have to, couple with that with the overall material balance and the component balance. Okay, something like that. So 14 equations. The first equation is C is equals to NV, or concentration is equals to moles per liter of the solution. Solution will be liquid 1 plus liquid 2. And then partition coefficient or distribution coefficient is equals to the activity. Okay, activity of liquid 1 over the activity of liquid 2 is equals to the solubility 1 over solubility 2. And then we have another equation, S1 plus Q is equals to 1, meaning the weight fraction of the solubility 1 is equals to 1. Okay, equation number 9, S1 plus S2 is equals to 1. Okay, equation number 10, V1 over V2 times K is equals to N1 and over N2. Equation number 11, N1 V2, the rise of N1 V2, okay, so Q1 minus Q. Equation 13, V2 over N2 is equals to Q1 minus Q. Equation 14, N2 is equals to V2 1 minus Q. Equation 15, there are 15 equations to be used. So this is V2, sorry, okay, V2 is equals to into 1 minus Q. Okay, muna yung gamiton. Now, the 1 and 2 designate the liquid 1 and the liquid 2. And it's very clear that the N is the number of moles, the V is the volume, okay, the M is the molecular weight, like that. Okay, and mass 1 is the mass also. Mass, not the molecular weight given in the problem. Now, if there are two binary what you call extraction, so you can use this formulas. Okay, apart from the, unless it will ask for the volumetric flow rate. So okay, what's the amount that goes in, that goes out, the overall material balance, component balance, because these are not yet component balance and the OMB. So component balance ngayon na jud kay siya katong percentage by mass, percentage by volume, okay, percentage by mole. Since tama sa kadiri mga N1, N2, okay, so kung makuha nimo ang N1, automatic nga nasa N2, makuha din nimo ang percentage by mole or mole fraction in terms of mole fraction. Since tama sa kadiri kuan, asa to ang gi-relate ha in terms of M1 weight. So asa to nga equation. O dire, naman sa M1, M2 dire ari, this is mass 1, mass 2. So you can also get the mass fraction later on here through this equation. Something like that. So the difference is percentage by volume, because the volume of liquid 1, both of them are liquid 1. That's what it calls binary extraction. Liquid 1 plus liquid 2. So they are both liquid. So that is your solute. Get the point? Okay. Or else you will add that water. It will form a solid substance after you put that in the, let's say, separatory funnel. And then you get, in the laboratory, you get the, what the goes on? A beaker, or shall we say, a flask? Something like that. Flask mo tawag niya. Beaker, di ba? Okay. Because ang flask, iba mo to ang flask. It's going to be the beaker. Okay, then you will put the separatory funnel has a bottom part, and you put a stop cup, just like like a gasket, a stopper, so that no liquid will fall pa siya sa beaker, something like that. You mix that one, you can say which are soluble part and insoluble part, and those soluble part, maram na siya sa bottom, will sink in the bottom, and there's a solid substance. A solid substance will go when you mix the two liquids. For example, liquid 1, liquid 2. For example, you have let us say sodium chloride, and you have, for example,